So we may be having this program which is for int I is equal to 0, I less than n, I plus plus. Okay, and here I am having a statement which is printf hi. Okay, now in this function, in this program, if you see how many statements are being executed or how many times the statements are being executed, if you see the first statement, it will be executed only once. If you see the second statement, it will be executed n times. If you see the third statement, it will be executed n times. If you see this printf statement, it will be executed n times. Now I'm going to say this program is going to take 1 plus n plus n plus n timestamps, which is equal to 1 plus 3n timestamps. Okay, and here this n is variable. If this n is variable, I can represent this thing by using a function like f of n is equal to 1 plus 3n. While if the size of n is bigger, then this value is bigger. If the size of n is smaller, then this value is smaller. Okay, so we can represent these statements by using a function. And this function will grow if the size of the input is growing or if the size of this n is growing. Okay, now this time complexity is given by the asymptotic notations. Let us see what are these asymptotic notations. Okay, so the next topic is asymptotic notations or asymptotic growth of functions. Okay, and this asymptotic growth of function is going to tell you what is the rate of growth of a function. This is a mathematical topic, discrete mathematical topic, but this topic is very much applied into this algorithm section, because here we can by using a function I can demonstrate at what rate a program may grow if you see some value. Now for example, in the previous program we have seen that we are having the function fn is equal to 3n plus 1. Now here in this case, if the size of n will grow, then the function will grow. That means the value of the function will grow. Okay, here also it is growing, right? So this asymptotic rate of growth of a function is going to tell us how or at what rate a function is growing. And here in this asymptotic notations, we use three types of notation. The first is the big O notation. The second is the big omega notation. It is big omega notation. And the third is big theta notation. Okay, so we are having these three majorly we use three asymptotic notations, which are big O, big omega, and big theta. Okay, now let us see what is this big O notation, and then we are going to see all these three notations. Okay, the first is big O, which is known by capital O. So in this big O notation, it is going to tell you, it is going to say, so in this big O notation, we will say, for example, if you are having two functions, maybe the function, this is a function fx, and there's some more function which is, assume this is the second function, and this function is gx. Okay, and then this is the x-axis, and this is some point which is the x0 point. So let me just clearly write it. It is, this point is the x0 point, and this is the x-axis. Okay, and more precisely we generally write it as c dot gx, or we will see what is this. Okay, so if in some case if you say this fx is always less than equal to c dot gx for all x greater than x0, then we say that fx is order of gx. Okay, this big O notation is called as the order of notation. Okay, so it is going to say if fx is always less than or equal to c dot gx for all x greater than x naught, and where c is a constant, then we can say that fx is order of gx. Okay, so let us take an example to elaborate this concept. For example, we are having fx as 9x plus 10 and gx as, assume it is x square. Okay, and then we are going to say, let us assume that value of c is 1. Okay, so if we compare these two functions like this, so this is the function fx, this is the function 1 dot gx because the value of c is 1. Okay, now let us see how these functions are growing, or at what point of time can we say that gx is greater than fx. Okay, so assume the value of x is 1. So if the value of x is 1, the value of fx will be 19 and the value of gx will be 1 only. If the value of fx is 2, x is 2, then the value of fx will become 28 and the value of gx will become 4. If the value of x is 3, then the fx will become 37 and gx will become 9. If the value of x is 4, then fx will become 46 and gx will become 16. If the value of x will become 5, in that case fx will become 55 and gx will become 25. If the value of x is 6, in that case fx will become 64 and gx will become 36. If the value of x is 7, in that case fx will become 73 and gx will become 49. Okay, so let me just extend this here. This is x, fx and gx. Now if the value of x is 8, then fx will become 82 and gx will become 64. If the value of x is 9, then fx will become 91 and gx will become 81. If the value of x is 10, in that case fx will become 100 and gx will become 100. So gx is also 100. Okay. Now if we put some value which is 11, in that case fx will become 119. So this is 99 plus 10 is 119 and the gx will become 121. If the value of x is 12, then fx will become 118. Okay, sorry, it was the previous value was 109, right? And if the value of x is 12, then it will become 118 and gx will become 144 and so on. Now if you see the specific point, what is the point? The point is 10, when the value of x is 10. After this value of x is 10, gx will always be greater than fx. If you put any value which is greater than 10, gx will always be greater than fx. But before this value of x as 10, it may happen that their values may fluctuate. That at some point of time you may find out that fx is greater than gx. At some point of time you may find out that gx is greater than fx. Right? For example, in this graph also, if you see before this point x naught, their values are fluctuating. That means at some point of time gx is becoming greater than fx. At some point of time fx is becoming greater than fx. Fx is becoming greater than gx. But after this point x naught, gx is always greater than fx. Gx is always greater than fx. So if this thing happens, then we say that fx is order of gx. Here also I can say that fx is order of gx. Okay. Now let us take few more examples. Assume we are having fx as 99x square plus, let us suppose, or make it simple because it will be difficult to calculate. So make it, assume we are having x square plus 10x plus 100. Okay, and we are having gx as x cube. Now let us see, can we say that fx is order of gx in this case? Okay, now let us see, can we say this thing or not? So assume this is fx, this is gx. Okay, so as remember, what is the definition? Definition is fx should be less than equal to c dot gx for all x greater than x naught, and c is a constant. So this is a constant number, which is a finite number. So here let us assume that value of c is 1. Right? So if the value of c is 1 and we are having this fx, so let us put some values of x. So assume this initial value of x is 1. So when the value of x is 1, so this fx will become 1 plus 10 plus 100, which is going to give you 111, and gx will become 1. If the value of x is 2, then fx will become 4 plus 20 plus 100, which is going to give you 124, and gx will become 8. If the value of x is 3, then fx will become 9 plus 30 plus 100, which is going to give you 139, and gx will become 27. If the value of x is 4, in that case fx will become 16 plus 40 plus 100, which is going to give you 156, and gx will become 64. If the value of x is 5, in that case fx will become 25 plus 50, which is 75 plus 100, which is 175, and gx will become 125. Right? If the value of x is 6, in that case fx is going to give you 60 plus 36, which is 96 plus 100, which is 196. And in this case gx is going to give you some number which is maybe 216, if I am correct. So 6 cube is 216. Okay, so let us suppose the value of x is 7. So if the value of x is 7, then fx is going to give you 49 plus 70, which is 119, plus 100, which is 219, and the value of gx will be 343. And if you take any value after this, 8, 9, 10, or so on. So if you see here that when the value of x was 5, during that time fx is greater than gx, but when the value of x became 6, after this time this gx is always greater than fx. Put any value which is greater than 6, any value, maybe 1000, maybe 1 lakh, maybe 10 lakh. So after this you will find that gx is always greater than fx, right? Therefore we can say that fx is order of gx where this x is greater than 6 or greater than equal to 6, okay, and c is 1. So c is a constant, so it is 1. So here we can say that fx is order of gx. Okay, so assume we are having this function. So maybe let us suppose we are having fx as x square plus x plus 10 and gx as x square. Now in this case, can I say that fx is order of gx? Can I say this thing? Okay, so in this case let us take some values here. So assume this is fx and this is gx, and here I can assume a value of c, right? So I told you c is a constant, and this constant is going to have a finite number, not an infinite number, it is a finite number. So assume here the value of constant of the value of c is 2, so it is 2.gx, and then let us put the values here, put the values for x. So when the value of x is 1, then fx will become 1 square plus 1 plus 10, which is going to give you 12, right? And this gx will become 2 into 1, which is going to give you 2. Now assume the value of x is 2. So when the value of x is 2, then fx will become 4 plus 2 plus 10, which is going to give you 16, and gx will become 4. So gx will become 4 into 2, which is 8 actually. Gx will become 8. Now the value of x is 3. In that case, fx will become 9 plus 3, which is 12. 12 plus 10 is 22. Therefore, fx will become 22. And gx will become 9. So 9 into 2, which is 18 actually. Right? So let us suppose the value of x is 4. So when the value of x is 4, then fx will become 16 plus 4, which is 20. 20 plus 10 is 30. And gx will become 32. So it is 2.x square, right? So this will become 32. If the value of x is 5, in that case, fx will become 25 plus 5, which is 30. 30 plus 10 is 40. And gx will become 25 into 2, which is 25 into 2 is 50. Right? Now the value of x will become 6. Then the value of fx will become 36 plus 6, which is 42. 42 plus 10 is 52. And the gx will become 36 into 2, which is going to give you 72. And so on. Now if you see, after this point of time when the value of x became 4, gx is always greater than fx. Therefore I can say that fx is order of gx. Okay, because I took some value of c. Now after seeing this question, you may be having a doubt that we can take the value of c in such a way that fx is always greater than gx. For example, if you see, we are having two functions. You may be thinking about this. So let us suppose the function is x, assume it is x square plus 4x plus 10, and gx is only x. Now can I say that fx is order of gx? So this is a most natural question, because I'm saying fx is c dot gx. So maybe if we take a very large value of c, if we take a very large constant, then we can make gx is greater than fx in any case. Okay, so let me just clear this doubt here. So assume this is fx and this is c dot gx, and assume the value of c is 1 lakh. Okay, or let us suppose the value of c is 10,000 or 1,000, because that will be easy to calculate. So 1,000 dot gx. So you can take any bigger value. Maybe you can take a value which is 1 lakh, you can take a value which is 10 lakh or 1 billion or 2 billion or 1 million, so on, whatever you like. And this is x, right? So if you take initially, if I take the values, if I take the value of x is 1, then fx will become 1 plus 4, which is 5. 5 plus 10 is 15. But if you take gx as 1, then gx will become 1000. Right? And you may be taking a lot of values after this. So maybe you took a value which is 100, or which is, okay, let us take the value which is 100. So if you take a value which is 100, in that case fx will become 100 square, which is 10,000, and then for 4 into 100, which is 400, plus 10, which is going to give you 10450. Okay, so it's the value of fx, which is 10450. And what is the value of gx? Gx will become this much. So here you can clearly see that gx is greater than fx. Okay, let me just jump more. Let me just take the value of x as 1000. So if the value of x is 1000, in that case, what will be the value of fx? So fx will become this much. This is x square plus 4x, which is 4000 plus 10. So this is going to give you 1004010. So this is 1,004,010, or you can say 10,04,010. And what will be the value of gx? So gx will become this much only. Right? So if you see, after this point of time, if you took the value of x as 1000 after this point of time, fx will always be greater than gx. It will not be the case that gx is greater than fx. It will be the case that fx is greater than gx. That means this criteria fx is less than equal to c dot gx for all x greater than x naught. This criteria will be failed. Why? Because if you take any value, then fx will be greater than gx after some point of time. Before that point of time, their values may increase. Right? If you see the graph is like this. So it is, assume this is fx, assume this is c dot gx. Now if you see, this graph is open at this direction. This graph is open here. There's nothing. That means we can assume a very large value of x, and x is actually tending to infinity. Right? If you take any value of c, you may be taking the value of c as 1 billion. And if you take a very large value of x, then you will always find out that in this case that fx is greater than gx. Therefore, in this case, I cannot say that fx is order of gx. Okay? Assume we are having this function. The first function is fx is equal to x square plus 4x plus 1000. Or let us suppose it is 1 lakh. Okay, and then we are having gx is equal to x cube. We may be having g2x is equal to x square. We may be having g3x is equal to x raised to power 4. We may be having g4x which is equal to x square log x. We may be having g5x which may be having x square under root x. We may be having g6x which is equal to x square raised to power 10, right? You may be having g7x which is x raised to power 5, right? So in this case, I can say that fx is order of gx. I can say that fx is order of g2x. I can say that fx is order of g3x. I can say that fx is order of g4x. I can say that fx is order of g5x. I can say that fx is order of g6x, and the fx is order of g7x. I can say this, right? So if you see, this gx is giving an upper bound to fx. So if you see the graph also, so this was the graph. So this is gx and this is fx for all values of x greater than x naught, right? If you see, gx is giving an upper bound to fx. So what is this upper bound? This upper bound is going to tell whatever will be the value of fx. Whatever, if you give a very big amount, very big value to x, then whatever will be the value of fx, gx will always be greater than fx for all x greater than x naught, right? So that means gx is actually giving the upper bound to fx. And there may be a lot of different upper bounds. There may be an upper bound where gx is equal to x cube. It will also give an upper bound. If you take gx is equal to x raised to power 4, it will also give you an upper bound. If you take gx is equal to x raised to power 10, it will also give you an upper bound. There may be a lot of different upper bounds, right? But we are not interested in all these upper bounds because there may be infinite number of different upper bounds. If you take x raised to power 1000, that is also an upper bound for this function. We are not interested in all these upper bounds. We are just interested in the tightest upper bounds. The term is tightest. Okay. So the upper bound which is closest to fx is called as a tightest upper bound, right? So here in this case, which one of these upper bounds is the tightest upper bound? So if you see, this g2x is giving the tightest upper bound. Okay, and what is this tightest upper bound? This tightest upper bound is given by the highest power of this fx. So this tightest upper bound is given by the highest power of this fx. Now for example, if you are having fx as, so this is some other function, maybe fx as x raised to power 4 plus 9x square plus, assume it is 8x cube plus 1 lakh. So what will be the tightest upper bound in this case? So the tightest upper bound is given by the highest power, so which is x raised to power 4. So if you are having gx as x raised to power 4, then we can say that this is the tightest upper bound for this above function. Okay. Assume these two functions. So there's a function which is fx as x square and gx as 2 raised to power x. Now out of these two functions, can I say that fx is order of gx, or can I say that gx is order of fx? How will we find out this? We can find out this by putting some values of x. So assume this is the table where we are going to put the values of x. Assume the value of c is 1. So this is fx and this is gx, and this is the value, this is x. So if x is 0, or let us start with 1 only. If x is 1, the value of fx will become 1 and the value of gx will become 2. If x is 2, then the value of fx will become 4 and the value of gx will become 4. If x is 3, then the value of fx will become 9 and the value of gx will become 8. If x is 4, then the value of fx will become 16 and the value of gx will also become 16. If x is 5, then the value of fx will become 25 and the value of gx will become 32. If the value of x is 6, then fx will become 36 and gx will become 64. If the value of x is 7, then fx will become 49 and gx will become 128. Now if you see here, after this point of time, when the value of x is 4, gx is always greater than fx. Therefore we can say that fx is order of gx, and this statement is not valid in that case. Okay. Now before this point of time, if you see clearly here, at some point of time it may happen that fx is order greater than gx. At some point of time it may happen gx is greater than fx. At some point of time their values may be equal. Right. So here you can justify the graph. So what was the graph? Graph was this, that before this value of x naught, their values may fluctuate. It may happen that at some point of time fx is greater than gx. It may happen that at some point of time gx is greater than fx. Before this point of time, their values may fluctuate. Before this value of x, actually, not point of time. So their values may fluctuate. But after this value of x is greater than x naught, gx will always be greater than fx. Okay. Now let us take one more example. Assume fx as 36, okay, and gx as 1. Fx as 36 and gx as 1. Now can I say that fx is order of gx? Yes, I can say this. How? Let me just prove it. So let assume the value of c is 37. Here there's no x in these terms, so there's no x here, there's no x here. But if you take c dot gx, then c dot gx will become 37 into 1, which is equal to 37, and 37 is actually greater than 36. 37 is actually greater than 36. Therefore I can say that fx is order of gx. Right? Now if I take, for example, fx as, assume fx as x plus 9 and gx as 1 billion. Let me take some very big value. So this is the value of gx. Now can I say that fx is order of gx? Here. Can I say this? Now if you see this, we cannot say that fx is order of gx. Why? Because if you take a very large value of x, then fx will become gx, because I already told you that x is tending to infinity. Okay. Now if x is tending to infinity, can I shift the point of x? See here, when will x be greater than gx? When will x be greater than gx? When this value will be greater than this complete value. To make it greater than this complete value, we have to assume the value of x which is close to this one. Okay, then that means you are saying that x0 should be greater than equal to some value which is 9 less than this value, complete value, and which is a very big number. Now the question is, can I shift the value of x0? Can I shift this point that what should be the value of x where this fx is greater than gx, right? So we can shift this value by increasing the value of c. So assume c is 1 lakh, then this value will decrease. Assume that c is 10 lakh, this value will decrease. Assume that c is 1 billion, then this value will decrease. X0 value will be decreasing. Okay. Now coming back to our previous programs. So the first program was something like this. Main. We printed this printf high, and this was 30 times. Okay, and the second program was main for int I is equal to 0, I less than 10, I plus plus, and here we will be having printf statement, printf high. Okay, and then we are also having this some other program which is main for int I is equal to 0, I less than n, I plus plus, and then this printf statement, printf high. Now in these two programs, I'm going to ignore what is the time which will be taken to execute main function, this main only. So I'm just going to see what is the time for this printf statements. Okay. Now in this printf statement, this will be executed 30 times. This is if I say that what are the number of statements here which are executing, it is 30. I can represent this 30 with a function. Fx is 30. Why? Because the value of x is actually constant here. The value of x is 1, so it is fx is equal to 30, which is a constant number. Here if I say gx, here gx, it is here number of statements which will be executed is 1, 10 times, this is going to be executed 10 times, this is going to be executed 10 times, and this is going to be 31 only, right? Now here if I take g1x as 1, and here also if I take g1x as 1, then I can say that here fx is order of 1. Therefore, if I see the time complexity, and if I give the time complexity by rate of growth, that means at what rate this function is growing, then we will find out that the time complexity is order of 1. Here if you see the rate of growth, here also the rate of growth is order of 1. Right? Now if you see the program here, so this statement will be executed one time, this will be executed n times, this will be executed n times, and this will be executed n times. So if I represent this complete with the function fn, then this will be 3n plus 1. Here this function is growing by the value of n, right? So if I take, let us suppose gn as n, then I can easily prove that fn is order of gn. And this is the tightest upper bound. As I have already told you what is the tightest upper bound, this n is the tightest upper bound for this program. Therefore, this program, the number of statements which will be executed will be order of n. And this is called as the time complexity. That is, what are the number of statements which are being executed. Okay, number of statements gives you the time complexity. Okay. Now let us take few more examples. Assume we are having this program. So this is for int I is equal to n, or make it just int I is equal to 0, I less than n, I plus plus, and then we are having for int j is equal to 0, j less than n, j plus plus, and then we are having a printf statement, printf high, right? Then what will be the time complexity for this program. So here when I'm saying time complexity is given by what are the number of statements which are being executed, and more precisely if I say it is the rate of growth of this number of statements. Okay, so here this statement will be executed only one time, this statement will be executed n times, this statement will be executed n times. Then how many times this statement will be executed? This is the question. Okay, so this statement will be executed n times. Why? Because of the outer loop. So whenever the value of I will increase, this statement will be executed, right? So outer loop will run n times, therefore this inner loop here, this statement will be executed n times, because every time the loop will run, this statement will be executed. And this statement will be executed n square times. This statement will be executed n square times. This statement will be executed n square times. Okay, you can easily see it like this. Okay, I'll show you what I'm saying. So here if you say this fn is equal to 1 plus n plus n plus n plus n square plus n square plus n square, which is going to give you 3n square plus 3n plus 1. So this is fn. Now let us assume we are having a gn which is equal to n square only, because this is the tightest upper bound to this. We may be having a gn is equal to n cube, but this is the tightest one. Okay, now can I say that fn is order of gn? So it is, let me write it clearly. Can I say that fn is order of gn? Okay, so we have already discussed this. We can say that this fn is order of gn. That means for this program the rate of growth is order of n square, or the time complexity is order of n square. Okay, now let us take one more example. For example, we are having this program for I is equal to 0, I less than n, I plus plus, for j is equal to 0, j less than n, or make it, because the previous was less than n, so let us make it less than I, and then j plus plus, and then we are having, assume we are having a printf statement. So printf hello, any statement, you can use any statement here. Okay, so assume we are having this program. Now in this program, how many times this statement will be executed? It will be executed one time, this will be executed one time, this will be executed, so this will be executed n times, and this will be executed n times. And how many times this will be executed? It will be executed n times. But the question is how many times this statement will be executed, because whatever the number of times this statement will be executed, this statement will be executed that many times also, and this statement will also be executed that many times. But what is the problem here? The problem is the value of j is actually dependent on the value of I. The value of j is dependent on the value of I. Now you have to identify how many times this j statement and this printf statement will be executed. Okay, so assume, let us suppose we are having this I, and this is the value of j. Okay, so here the value of, initially the value of I is 0. Then if we are having j less than or equal to I, then j will be executed one time. If the value of I is 1, not 2 actually, then j will be executed 2 times. If this j loop, actually when I'm saying j, it means j loop, if the value of I is 2, then j loop will be executed 3 times. If the value of I is 3, then j loop will be executed 4 times. If the value of I is 4, then j loop will be executed 5 times. If the value of I is 5, then the j loop will be executed 6 times. And the same way, when the value of I is n minus 1, then j loop will be executed n times. Then how many times did j loop executed? If we add all these numbers, then we can find out that how many times j is executed. J loop will be executed. So what is this? 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus up to so on n, and this number is going to give you n into n minus 1 by 2, because it is a sum of n natural numbers, which is going to give you n square by 2 minus n by 2. This is n square by 2 minus n by 2. That means this statement will be executed this many times, n square by 2 minus n by 2. This statement will be executed this many times, and this statement will be executed this many times. So if you add all these numbers, then you are going to get 1 plus n plus n plus n plus n square by 2 minus n by 2 plus n square by 2 minus n by 2 plus n square by 2 minus n by 2. So because these statements is actually for this one, and this one. Okay. Now if you add all this, you are going to get a number which is maybe it is here n square plus n square plus n square, which is 3n square by 2 plus n by 2 plus 1. So if let us suppose I represent this by fn and then assume that gn is n square, then because n square is the tightest upper bound to this, see, whenever we found this tightest upper bound, we always ignored the constants. If you see the previous cases, we always ignored the constants. Okay. So here gn is equal to n square, therefore I can say that fn is order of gn. Therefore the time complexity for this program is order of n square. Okay. Now let us take more examples here.